Aloha, EDEE 464 Ohana, and welcome to the new reality that we're going to be experiencing for a bit. And so instead of doing our normal activities that we would done in lab today on Monday the 23rd, what we're going to be doing is a virtual lab, and I'm going to go through a little bit of it with you so that you have an idea about what it is that I'm talking about. So um, what we're going to have to do is I'm going to have to get to this website here. And this is the virtual pendulum lab that we're going to be doing. And you'll notice that there's a link right here in the materials. And typically, the list of materials would be a lot longer. And so, what we're going to be doing is going through the lab, and I'm going to want you to do the various, respond to the various questions, but I want to go through the setup basically. Okay, so we linked to the website. We're going to click on this forward arrow on the Pendulum Lab, and you have your choice of intro, energy, or lab. I want you to highlight lab. So by clicking on it, then click on it again. And then I'm going to move this slightly out of the way here so you can see a little bit more what's going on. Then I want you to select the timer box. So over here on the left side, you'll notice that there's ruler, which is essentially a ruler. There's a stopwatch, which we're not going to be using right now. And then there's the period timer. I'm going to move this period timer over to the left side. You can put it wherever you want, but for my sake, it seems to be a little bit better location. So what is the period of a pendulum? Well, the period of the pendulum is the time that it takes it to move from wherever it starts back to that position. So that would be one period. So we're going to go ahead and take a look at this in just a minute. But once you start, the pendulum will be clicking on the period timer. So I want you to take a look over here on the right side, and there's gravity. Earth is the default gravity. There are other choices: the Moon, which is about 1/6 of Earth; Jupiter, which is considerably higher than Earth; some exoplanet, and then you can create your own. But let's go ahead and stick with Earth for the time being. Friction's right below it. We do have friction. It'd be nice if we didn't have friction because then these pendulums would move forever. But in this case, we're going to take the slider and move it to about the middle. So I'd say that's probably about right for here. And then you'll notice it says set the length to the amount given on the data table and the mass to the amount given on the data table. And then click on the mouse and drag it to the desired angle. So the data table we're going to be looking at first is data table 1. And that's down past the bottom here. So you're going to have a graph you're going to get to work on a little bit later. So here's data table 1. And so for data table 1, we have the length in meters. That's what the M stands for. Mass in kilograms, height in degrees. It really could say angle, but in this case, it's the height that you're lifting the bob, the plumb bob, this weight. And then we'll have the timer going. So I'm going to change the size of this slightly because I want to be able to get everything where I can see everything together. Okay, and I'm going to move this guy over. So when I click on that, yep, it's still visible. Excellent. Okay, so what it's saying is that for pendulum A, which you can do however you want to do, but it makes sense to do it A, B, and C. In trial 1, and for all of these, you'll notice that the length has been kept constant, and in this case, the height has been kept constant, the angle, but there's a variable here, which is mass. So this is giving you a hint about what a couple of the variables can be. So the length is 60, so it says it's 0.7, this says 0.6, and so we want to move that over to 0.6, and then we're going to take the mass, and the mass is going to be 1.5, so 0.5. And so now my mass is 0.5, the length is 60 or 0.6, it's 60 centimeters, which is 0.6 meters. And we'll go ahead and lift it now up, drag it up till you get to 30. That's what we're going to work with, 30. And then you're going to go ahead and release it and then hit period. And you'll let it swing and then you can stop it. And now what I'm going to do is I'm going to enter the period in seconds. And I get 1.5. And I'm going to call it 5.8 because we really aren't going to get human reaction time, you guys should know, is about 0.2. So anything within 0.2 is going to be considered no difference. So then when you can hit this again, actually it won't matter. We're going to go now and we're going to change the mass to 1 kilogram. And we're going to raise it up to 30 again. Let it swing, hit the period. And then we'll hit that stop button here at the bottom. And then I've got right now, I'm going to put in 1.58 again. And then we're going to do one more. I'm going to change this to 1.5. And we're going to raise this guy up to 30 again. We'll let it swing. And we'll stop it. And again, 1.58. So this is pretty straightforward. In this case, the average of the time in seconds is 1.58. So you should have no problem figuring out how to do this. So you notice that in this case, in pendulum B, you're keeping the length again at 60, which is not going to be a problem to change. You're going to change the mass back to 1. So the mass and the length will be constant, but in this case, you're going to do 15, 30, and 45. And so you have 15 is right there. We know what 30 is, and then 45. Okay? And we'll not worry about it right now, but because I want you to collect the data. So once that you have your average times, you can actually this one you probably won't. You can use the average on this one, that's fine, but these lengths are going to become increasingly important. And then in this case, the last pendulum, you're changing the weight, keeping the angle constant, and again the mass constant. So what I'm hoping that you see is that we're only changing one variable in each of the cases. That's the important thing to recognize. So once you've got all your data collected, then what you have up here is some information about what's going on with energy. I want you to respond to the questions. And then I also would like you to write down what your period in seconds. It's obviously going to be between 1 and something. We don't know exactly what yet. And your variable, whatever variable you decide, is it going to be the mass, is it going to be the length, or is it going to be the angle. And so if it's 15, it'd be 15, 30, 45. And if it's the weight mass, it's 0.5, 1.0, 1.5. And if it's going to be the length, it's going to be whatever I gave you, 30, 60, 90. Okay? So that shouldn't be too hard to figure out. And then, of course, period, which is in seconds, and you can see how that works. So that looks like that's about and then down here at the bottom, what I'm giving you an opportunity to do for data table 2 is that once you understand which one of these 3 variables that we're looking at is important, I've got an opportunity for you you can formulate a hypothesis to explain your variation in the pendulum. And then I want you to construct new pendulums to test your hypothesis formulated in step 6. In this case, you can change gravity and friction as variables. Just remember to only change one variable at a time. So in this case, you've got another data table, and this Kansas data table is a little bit bigger. You now have 5 variables. We're looking at gravity and friction, and so you have choices here. You can make the gravity like the moon, you can make the gravity the Earth, you can make the gravity Jupiter, holding everything else constant. Then, or you can keep the gravity Earth, and you can go to none, you can go to middle, you can go to a lots for friction. You can change these lengths. The maximum length is a meter, the minimum length is 10 centimeters, a tenth of a meter. And you can do masses from 1 gram, from 10 grams, excuse me, up to 1500, which is 1.5 kilos. And so you can check out how that stuff works too. So then once you've got a chance to plot that, you can see which variable of these, if friction has something to do, if gravity has something to do, and again, if it's length, mass, or height, or in this case, the angle you drop it off. So I think that should do it for you. And then, of course, you will have your learning center to look at. And so I haven't posted it yet, but in your assignments, there'll be a learning center dealing with pendulums and a couple of articles to take a look at as well. And then following week, we will have something else for you to do. But I would like to say that if you have an opportunity to come to school, the lab will be open and available, and I will be trying to make up some lab packs for you that you can take to do some of the activities at home with, because I know not everybody can get access to the stuff. So take care of yourselves, stay healthy, and I look forward to talking to you guys virtually. I have office hours from 11:30 until 12:30 on Mondays, and we can set up and have a virtual class time as well from 2 to 3 if anyone's interested. So we'll talk to you guys later. Take care. Bye-bye.